All right, so we're going to be comparing and ordering numbers in scientific notation. So this is a document that I have found on the internet, and you will see it down in the comments where I got it from. There'll be a link. So it's giving us a step-by-step guide on how to compare and order numbers in scientific notation. So the first part here is to understand each number in terms of scientific notation. So anything that's not in scientific notation, I'm going to have to convert. So go look at my practice sample, and I have 2.34 times 10 to the 5th, and that is already in scientific notation. 3.9 times 10 to the 6th is also in scientific notation, but the 3,800,000 is not. So what I need to do is I'm wanting a decimal point to be right here. And since I'm going to be making that a larger number, I'm going to make it to however many places it takes for me to move that decimal place from here over to here. So I want to go 1, 2, 3, 4, 5, 6. So that makes us 3.8 times 10 to the 6th. Here I have 4.2 times 10 to the 5th is in scientific notation, but my 58, let's see, 10 hundredths, 58 10,000ths, I am going to have to change. So I'm going to be 5.8 times 10, and I already know it's going to be a negative exponent, but let's see how negative it's going to be. So I'm going to go 1, 2, 3, 4. So it's going to be 5.8 times 10 to the negative 4. And so now I have 3.8 times 10 to the negative third. That's also in scientific notation. So I've got everything in scientific notation, so check. And now we're going to compare the powers of 10. And what it's asking me to do is group all of the same powers of 10 together. So I'm noticing that I have a couple of 10s to the 5th, and I want to place them in order from least to greatest or greatest to least. I'm going to, since my stacking here is greatest to least, that's how I'm going to do it. So I'm going to look at this number here, 2.34 times 10 to the 5th, and 4.2 times 10 to the 5th, because I can see that they both have the same power of 10. And so now I'm just going to really evaluate this number. 4.2 is bigger than 2.34. So that's going to go over here. So I'm going to put 4.2 times 10 to the 5th. That's larger than 2.34 times 10 to the 5th. And so I grouped it right here with my 10s to the 5ths. And now I'm going to look and see, I have 2 that are 10s to the 6th. Let me go ahead and change the color of my pen. Let's do these in green just so we can see the difference. So I have a 3.9 times 10 to the 6th and then 3.8 times 10 to the 6th. Well, 3.9 is bigger than 3.8, so let me stack it up. So I'm going to do 3.9 times 10 to the 6th and 3.8 times 10 to the 6th. Let me change another pen color. I'm doing another grouping. So let's change that one to red. And I have, let's see, none of the rest of mine are in the same category, so that's okay. So here's my 5.8 times 10 to the minus 4th, which is here. So I have 5.8 times 10 to the minus 4th. So that's that one. And then let's go ahead and use black for the other one. And then I have 3.8 times 10 to the minus 3. So now I have them in order. So I group them together with the same powers of 10. And then I compared them, and I know 3.9 is bigger than 3.8. And I love how I have this little guide here. 10 to the 0 here is 1, and then it goes up from there. And then it gets smaller as I go this way. So my smallest number here is going to be 5.8 times 10 to the minus 4th, and then we're going to get progressively bigger. So it's important to group them together, and this is a really great guide for it, and then look at the numbers within the same groupings. Okay, so we're going to do some more practice for a few more of these. So let's go ahead and erase some things, because we're going to go ahead and do another set of them. All right, so now we're going to look at the next set. So let's go ahead and change to our blue. Oh, so this one's nice. So I'm looking at this one right here, and we all have the same set of numbers over here, 4.58, but we have different powers of 10. So if I'm not quite sure which ones are which, I could go ahead and put them over here. So let me go with 10 to the 6th. So this is 4.58 times 10 to the 6th, but then I have 4.58 times 10 to the minus 6. This is a very small number. This is a pretty large number up here at the top. Then I have 4.58 times 10 to the 3rd. 4.58 times 10 to the 3rd. And then I have 4.58 times 10 to the 0. And so I would go ahead and place them in order. So let me just do this. I'm going to do 1, 2, 3, 4. And it said least to greatest. So I want the smallest one. So that would be 4.58 times 10 to the minus 6. So I'm going to say number 2 is the smallest one. And then the next smallest one is 4.58 to the, oops, I said I did that one wrong, times 10 to the 0. Let me get my eraser in for that piece right there. Sorry about that, I wrote it completely wrong. And so that's going to be number 4. So 2, 4, and then 10 times 4.58 times 10 to the 3rd is number 3. And then the last one is 4.58 times 10 to the 6th, which was our number 1. So you can write it in this order where you've given it a number, or you can actually write it out. It's up to you. All right, so let's look at a few more. So we're going to go ahead and do this one right here. So let me get my eraser out. I can clean up and use this some more. All right, I'm going to change my pen color just so my examples are a certain way. So now place the numbers in order from greatest to least. So I'm going to work on this one right here. So I'm noticing that I do have some different values. And I do have some things I need to convert. So first thing I do is convert everything to scientific notation. So this is going to be 3.178 times 10 to, let's see, 1, 2, 3, 4, 5, 6. This is 10 to the 6th. And then I have to change this one too. This is going to be 3.17. And I want that right there, so I'm going to see how I move to go there. I go 1, 2, 3, 4, so that gives me times 10 to the negative 4. Okay, so what I'm noticing is that I have 2 of them that are in the 10 to the negative 4. So I have to really decide which one is smaller or larger. So I have 3.17 times 10 to the negative 4th, and I have 3.178 times 10 to the negative 4th. So the smaller one is this 3.17. So I'm going to go ahead and stack that up here. 3.17 times 10 to the negative 4th. And then a little bit bigger than that is 3.178 times 10 to the negative 4th. And so that takes care of this one and this one. And now I'm looking at, oh, I have a negative 5 here. So this is going to be down below. 9.26 times 10 to the negative fifth. And then this one is a lot larger. This 3.178 times 10 to the 6th is way up here. So I have 3.178 times 10 to the 6th. So you can see how important it is to understand if something is a very large number or a very small number. And so then if I'm looking at this, let's use letters this time. Let's call this one A, this one B, C, and D. So the order that I would want, they're going from greatest to least. So I'm going to want B, because that's the big one, right? That's the big one. And then I'm going to want 3.178 times 10 to the negative fourth is A. And then I have 3.17 times 10 to the negative fourth. That one is D. And then finally I have C. So that's the order that it's going to go in. All right, so let's do one more example of how to do this. So let me go ahead and erase what I have here. And now let's do this one in green. So this is a little bit different. It says use greater than, less than, or equal to compare the numbers below. So I'm going to go ahead and write 8.5 times 10 to the negative fifth. So it's right here, 8.5 times 10 to the negative fifth. And then I have 8.5 times 10 to the negative third. Well, I have to keep in mind that as I go in this direction, hang on. As I go in, let's do that in a different color. Let's do that in blue. When I move from, so 10 to the 0 is 1. When I go in this direction, things are getting smaller. And when I go in this direction, things are getting larger. So 8.5 times 10 to the minus 3 is going to be larger than 8.5 times 10 to the negative fifth. But it's in the other way around. So let's look at it. If I'm going from 8.5 times 10 to the minus fifth, it is less than 8.5 times 10 to the minus 3. Let's go back to our green so that we're consistent. So what I just said was 8.5 times 10 to the minus fifth is less than 8.5 times 10 to the minus 3 because it sits below it, because this is a bit of a number line, right? So here we go, and let's look at our next set. So we have 3.7 times 10 to the fifth, so that's going to be way up here. So 3, oops, I need my color. I'm going to have 3.7 times 10 to the fifth, and oh, they're both 10 to the fifth, so it's going to be 4.5. I know 4 is bigger than 3 times 10 to the fifth. So when they have the same power of 10, then I'm just really going to compare the numbers, and I know 4.5 is bigger than 3.7, or 4 and 5 tenths is bigger than 3 and 7 tenths. So let me look. How is it asking? Oh, so it's asking me what is the relation. So 3.7 times 10 to the fifth is less than 4.5 times 10 to the fifth. So I have to pay attention to those things as well. So again, I'm going to go ahead and erase that and look at the next set. And so here I have 2.35 times 10 to the negative 2, so that's here. 2.35 times 10 to the negative 2, so that's that first one. And then I have 2.53 times 10 to the second power. And so they're trying to fool you here by using numbers that are very, very similar. So you really need to pay attention to whether you have a positive or a negative. So even if these were exactly the same digits, definitely this one is smaller because it's a negative 2. So we're going to say 2.35 times 10 to the negative 2 is smaller than 2.53 times 10 to the second power. All right, one more to do, and then I'm going to leave the rest up to you to show me. All right, so now we have 6.04 times 10 to the 7th. 6.04 times 10 to the 7th, and then I have 6.4 times 10 to the 6th. So because this 10 to the 7th is larger than the 10 to the 6th, then that one is greater. So 6.04 times 10 to the 7th is greater than 6.4 times 10 to the 6th. And your assignment is to go ahead and check the other three. So to do the other three boxes and then submit that for your assignment. Thank you.